Two of maybe monads, what I'm going to do first thing is we're just going to define the type, the maybe type. So let's first define this. The way it's defined in Haskell is that data may be, now remember maybe is acting as a type constructor. Okay, so it's a type constructor, and let's say the maybe of some x here, okay, and x is basically a type variable, is equal to, I have a value constructor just there, it could be just x, or is basically nothing. Okay, so these are my value constructors here, that's my type constructor here, and it just tells you that it can potentially take in these two kinds of values. Okay, now I want to provide an implementation to the bind method, and in the last video we at least figured out what the bind method should be doing. It takes in a function f prime with that kind of a type signature, and it basically upgrades it to give you back maybe integer 2 and maybe integer. Okay, and so let's just explore this. Let's just explore the specific context that we had set up in our last video, and just go with that context to provide an implementation to this bind method. So first thing, what you're going to do is I'm just going to use a slightly different color here to provide the implementation, and I'm just going to use pattern matching here. So first thing, before getting pattern matching here, let's say bind. It takes as an input some f prime. Now remember, this is my type signature. This is my type signature here, and this is basically I'm going to provide an implementation. So it takes in some input f prime, and it takes in some value. It takes in some value. So let's call this some value x over here. Now because I'm using pattern matching, I can say that this value x of type maybe integer could be of two kinds. Via pattern matching, I know that's the first kind right there, and this is my second kind. So bind of f prime, if you're going to give me nothing, I'm just going to give you back as an output. I'm going to give you back as an output some value of type maybe integer, and this is going to be, in this case, nothing as well. Okay, so f prime, this f prime over here is that type signature. I have a value x of type maybe integer, and we get back another value of type maybe integer. Now, again, using pattern matching, bind of f prime. What if I have something that happens to be just of some value there? So if I say just some y. Okay, so this entire piece, just y, is basically of type, in this case, type maybe an integer. Okay, that's what I'm looking at, maybe an integer there. And y in this case, to be a little bit specific, at least with this type signature there, y is of type an integer. Okay, so again, just keep in mind that this piece over here, this entire piece over here, is of type maybe an integer, and this piece over here, y, this piece over here, y, is of type just an integer. Again, I'm just being consistent with this type signature that we had set up in the last video. Okay, and this is going to be equal to some value of type maybe an integer. Now, sure, I could give you back. I could just say this equals to just y. Okay, that happens to be a value of type maybe integer. At the surface level, everything seems to be in sync. Everything seems to be in sync with my type signature there. There's nothing wrong there, and this could be one possible implementation. But again, we haven't looked at the monad laws here right now. So once we look at monad laws, we're going to see that this is actually going to be incorrect implementation. But the other way, just to think about here, is I'm not making any use of my f prime there. I must be making use of my f prime somewhere in that implementation. So this is definitely going to be incorrect. I cannot have just y there. This is going to be definitely incorrect there. So I need to somehow make use of my f prime, and I know that f prime is a function that expects as an input some integer, and what I really need is some integer to apply that f prime with. I already know y over here. Y over here is some value of that happens to be of type integer. So why don't I take f prime first, take f prime and apply that on y, and I know that this f prime y, this function f prime, when it gets applied on y, gives you back some value of type maybe integer, which is completely what I expect the bind to give me back. So this piece over here, this entire piece over here, is of type maybe an integer. Okay, so this is an implementation of the bind method in the case of using a maybe monad, and the other thing that we're going to do right now is we're going to define an implementation to a return method. But before we do that, let's just write a monadic. Let's write the first the monadic law using function composition. So the monadic law is basically the way it's defined is that if I have the bind method, if I call the bind method on some function f prime, where f prime is a function that in this case belongs to that type signature that goes from integer to maybe integer. If I do this function composition with, in this case, I'm not going to use the word unit here, but let's just use the word return. Okay, unit and return are just aliases to each other. And let's just put a parenthesis. This is basically equal to bind of return function composition with f prime, which is equal to f prime. Okay, so this is one of our monadic laws that must be true at all times for something to qualify as a monad. Okay, so we have basically at least the three things that we looked at in lecture was that I should have this tuple of three entities: the bind method, the implementation to the return, or the unit method. And then of course you're going to define the type constructor M, and we'll explore this type constructor M a little bit later. But a tuple of these three entities is what defines a monad. And then again you have these laws that must be fulfilled when you provide an implementation to the bind and the unit method. Okay, so my question now is, what should this return method look like so that this entire law gets preserved here? Okay, so let's just think about, this is not going to be an exhaustive proof here, but just something that we're going to scratch at the surface level to see, just to get an intuition as to what this return method should actually look like. Okay, so f prime. F prime is a method that takes an integer. Okay, so let's just make something up here. So I'm just going to say, let's say this f prime takes in some integer 5. Okay, when it takes in this integer 5, out comes back a value of type maybe integer. Let's just make something up here. So let's say it comes back with a value of just of 7. Okay, I'm just making something up there on the fly for f prime there. Okay, so f prime takes in 5, gives you back a value of just of 7. Okay, so what happens with this function composition there? All right, so I know f prime is taking in a value 5. Okay, when it takes on value 5, this entire piece here gives you back a value of just of 7. Okay, and I know that whatever this value just of 7 is gets fed in as an input to this entire piece there. This entire piece, so let me just slightly use a different color. Okay, remember we did this in our last video. So this piece over here, this piece in yellow, is some kind of a function that takes in as an input just 7. Okay, as an input. And what do you get back as an output from this entire yellow piece there? Well, from this entire yellow piece there, bind takes in f prime, and it takes in some maybe integer. Out comes back some other value that happens to be of maybe integer. But I really want, in this case, I really want that if it takes in just 7 as an input, the output the output must be just of 7. And why is that? The output of this yellow box must be just of 7, because bind return function composition with f prime should be equal to f prime. If f prime's output is just of 7, this entire piece over here, the entire piece in this orange, I'm kind of going overboard with all my different colors here, but hopefully we get the point. Okay, this entire piece in orange must also give back an output of just of 7, just so that it's in sync with this piece set. Okay, so if it needs to give back an output of, okay, let's just hold on to that thought right there. So we know that this entire piece over here needs to be just of 7. Okay, let's just explore even this piece over here. Okay, so this return over here is going to take in as an input. It's going to take in as input, let's say some 5. Okay, when return takes in some input as a 5, well, out comes back some value. Okay, that I don't know what that value is going to be, but at least I know that the type signature of this orange box is going to be maybe an integer. How do I know that? I know that because bind of f prime expects as an input a value of type maybe integer. Bind of f prime, the type signature of bind of f prime is that piece right there. It goes from maybe integer to an maybe integer. So for this function composition to succeed, the output of return, whatever this output it gives you back, it could be any value, but the value must be of type. It must be of type maybe an integer. Okay, whatever this maybe this orange box is, this orange box then goes as an input into this entire piece over here. Okay, and such that bind of f prime must give you back as an output something that happens to be just of 7, right? Why should it be just of 7? Because only if it is just of 7, that's going to be in sync with this just of 7 that I got back after the equal sign, which is going to be equal to f prime of just of 7. It just, the entire law must just hold. Okay, so the question still is, what should this return look like? the answer is kind of right over here as we're playing with this simple example. I know that in this case, I can start exploring this orange box over here. What is this bind actually doing once it takes in, or what? Let's just think this way. What is this orange box actually doing when it actually takes in this piece as an input? So this orange box happens to be maybe integer that goes into this orange rectangle. And what this orange rectangle is essentially doing is going to take that value, whatever this value is going to break it up, is going to break it up such that the integer component of that orange box must go into f prime. So what should f prime do with that integer so that the output of the entire orange box is just a 7? Well, f prime must be taking in as an input something that should be 5, right? Because only if f prime takes in 5, only if it takes in 5 there, the output of f prime on 5 is going to give you back just a 7. So if f prime takes in 5, and if that 5 in this case, in this orange box must be encapsulated as maybe integer, this orange box must be just a 5, right? Only if this orange box contains just a 5, then this orange rectangle is going to basically tear it apart, is going to split it apart such that you get the integer component out. That's what bind actually does. It gets the integer component out from here and it feeds it into the function f prime. And only if f prime will get 5 here, because that's the assumption we made here, only if f prime takes in 5, you're going to get back an output of just a 7. So we know now what this return method is basically a method that takes in some x, right? In this case, x happens to be an integer, but doesn't need to be. But let's be sync with the type signature, which is return. Let's just write a type signature there. My apologies, getting really messy here, but return takes in some input of type integer and gives you back something that is a maybe an integer. We got the piece right there. Return takes in some value of type integer and gives you back this orange box that happens to be of type maybe integer. That's the type signature. So return x is going to be equal to just of x. Okay, it's going to be just of x, and make sure by using this law we know that return of x equals to nothing. Okay, this implementation is in complete sync with the type signature there. Okay, they're both in complete sync with type signature there, but that implementation of return is not going to be in sync with this monad law there that I've just proposed there. Okay, and this is the reason why return x should be just of x, and that piece is incorrect. That piece is incorrect there. Okay, so you can just play with that example if you're just over here, that if return takes in some integer 5, and if this orange box happens to be nothing, and if nothing goes into this orange rectangle there, what is bind going to do? Well, bind is going to simply, as far as implementation right there, bind of f prime, when it takes in nothing, it's just going to give you back a value that is nothing. So this entire piece is going to be nothing, which is not equal to f prime of 5, which is just 7. You have just 7 on one hand, and here you have nothing, completely unequal, and which means that the implementation of return should be, in this case, return x should be just of x there. Okay, so this is basically what the maybe monad is. We got the implementation to the bind, we got the implementation to the return, and if I were to just generalize this, remember we are playing with a very specific example, but if I were to just generalize this, where I had a function f prime, right? My function f prime was a function that went from an integer to maybe of integer. We're kind of looking at that specific example with g prime also happened to be a function that goes from integer to maybe integer, but I can make this a little bit generalized now. So I can say in this case, let's say int to some m of int, where this m over here is my side effect that's happening, and the side effect in this case is basically the side effect captured by the maybe monad. So it could be an exception, or it could be some kind of an error that might be generating in our code here. And you could think about a division of two numbers. So if I take in an integer, and what I get back as an output, the quotient, could be a maybe an integer, right? I don't get back an integer from there. I get back a maybe integer, because a division by 0 doesn't give you back an integer. You get back an error, and that error is captured by the value nothing. So in that case, the output is going to be maybe an integer. Okay, so this is how I generalize this, and then I can of course again make this a little bit, again making things really, I don't have space right there, but let me, if I can just get these things a little bit cleaned up here. Again, the way I generalize this is I can say type m in this case is nothing but equal to the type constructor, maybe. Okay, so now you can think about the bind method there. Instead of saying using maybe there, I can just make it m. I can just replace everywhere I see a maybe with an m there, and this is how I can even generalize to see what the bind method essentially does for every monad. Okay,